All right, Math 1 students, here's your Module 9 review. First thing I'm going to ask you is if you can identify the first step for calculating the following statistical measures. So mean, it means we have to add all the values together. Then after that, we're going to count the number of values that there are and divide by the number of values. But the first step, when we're calculating, is adding all those values together. The median is to put all the values or numbers in numerical order. And the mode is to count how often each value occurs. So remember that the mode is the most. So if we have a set of numbers, it's which one occurs the most. That's the mode. So we'd have to count. See, okay, there's 3 of these and 2 of these and 8 of those. Oh, maybe that's the mode. The median, remember, we have to find the middle when they're in numerical order. And the mean is where we take the average, add them all together, divide by the number of values. The following GPAs, so there, just before I move on, there are a number of answers that would be acceptable here, but if you add all the values, the numbers together for median, then that wouldn't be correct. If you put all the values in numerical order for mean, then that wouldn't be correct because while you could add them up in numerical order, it really doesn't make any difference. So that doesn't show you understand what the process is for finding these things. All right, so the following are GPAs of a school's basketball team. So we've got this many GPAs, and we calculate the following. The mean, okay? So mean is going to require us to add all the values together, like we just said. So I'm going to grab my calculator. Now, my strategy for doing this is I'm going to add them, I'm going to put them in order since I'm going to have to find the median. And when I put them in order, then it's going to help me count them up. And since I'm going to be putting them in order, maybe I want to do that by a box plot or by a dot plot. So I'm going to make my dot plot sort of underneath here because I got the workspace. So the box plot is coming, but a dot plot would help. So I know I've got somewhere between, let's see, the lowest value 2.1 maybe? Yeah. And the highest value is 4.0. So I'm going to have to somehow get from 2.1 to 4.0 here. Let's see, if I go 2.1, 2, 3, 4, 5, 6, 7, 8, 9, 3.0, 1, 2, 3, 4, 5, 6, I'm not going to get up to 4.0. So it looks like we're going to have to go by 2. So if I went 2.0, 2, 4, 6, 8, 3, 2, 4, 6, 8, 4, I'm a little better. So maybe we'll start here, 2.0, 2.2, 2.4, 2.6, 2.8, 3.0, 3.2, 3.4, 3.6, 3.8, 4.0. Okay. So I'm going to do this a little bit upside down so I still have the space for my box plot, just so you can be clear about what a box plot is. But around here I'm going to say, okay, I've got a 2.1. Well, I can just go in order. 2.8 is here. 3.9 is here. 2.1 is here. 3.2 is here. 3.6 is here. 2.8 again. 2.5. 2.1. Boy, these basketball players apparently aren't studying very hard. 3.8. Oh, there's somebody who's been working hard. 3.2, 3.6, 3.8, and 4.0. Okay. So now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 values. So the mean, I know I'm going to divide by 13. Okay, and so I'm doing a little bit out of order here, but let's do this. So I've got 2.1 plus 2.1 plus 2.5 plus 2.8 plus 2.8 plus 3.2 plus 3.2 plus 3.6 plus 3.6 plus 3.8 plus 3.8 plus 3.9 plus 4.0 equals 41.4. So divide that by 13 and I get 3.18. 3.18. Notice it's 3.184, so 3.184 means that I round down to the 3.18. The median. Okay, since I've already laid these out in order, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Good. So always worth a double check to make sure you haven't missed one. So that means that the middle value is going to have 6 on one side and 6 on the other. And the seventh, if I count 7 in, that's going to be the middle. 1, 2, 3, 4, 5, 6, 7. Here's my median. My first quartile and third quartile are going to be 1, 2, 3, 4, 5, 6. So that means I'm going to take these, and there's, oops, all right, here, Q1. Q1 is the average of, or the mean of 2.5. That's what this one is, and 2.8. Divided by 2 is 2.65. Oh, so median is 3.2. And then do the same thing here. 1, 2, 3, 4, 5, 6. So there is Q3 equals 3.8. Just to make sure we're clear on how we do this, the IQR here is going to be 3.8 minus 2.65. 1.15. So if we were looking at outliers, we would need to know this. So now it says draw a box plot. Okay, so here's my 2.65. There's my Q1. I'm labeling this, but you're not required to label box plots as long as it's in the right place. Here's my minimum. Here's my median. Here's my Q1. And here's my maximum. Draw the box, and there's the whiskers. This is a mistake from earlier. Let me just make sure that's not confusing anybody. There. So there's my box plot. Okay, so bear sightings in Yosemite. So now it says, tell me the IQR, and tell me the IQR. IQR here is going to be pretty straightforward. This looks like maybe the graphics didn't line up. So is this, what, 11.5? That's possible if you had an interquartile range of, if you had a quartile that was an average of values, you could have an average of 11.5 sightings in the, or a quartile of 11.5 sightings. And this one looks like it is right there, 23.5. 23.5. I can't write today, apparently. So this is 11.5. Go 11.5, and then so my IQR here, 23.5 minus 11.5 is, boy, I don't even want to think right now. 23.5 minus 11.5 equals 12. I could figure that out in my head if I really wanted to, but I'm feeling maybe a little spent. So, and when you're taking a test, it's always good to do a double check. If you've got a tool, you use it. The range is going to be between 25 here, max is 25, and minimum is 10. So 25 minus 10 equals 15. Now let me tell you, if on a test, if you write these numbers down and I can see, and then I see, oh, you know what, you actually, you said 12, but it's actually 11.5, right? I might not take off any points, or maybe just one, if anything, if I see that you're just, not quite visually picking this up. But if you get me the wrong IQR and I don't see your work, I can't see what numbers you're using, then I have no idea how you got to the wrong answer. So make sure that when you're doing the work, even if it's something you can do in your head, write it down, because then you're showing me the process, and you have a chance for partial credit. Okay, IQR over here. I started here because the box plot just gives me my quartiles. That's just a matter of reading it. Here I have to kind of figure it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17, that means that if 17 is the number, sample size, then that means I'm going to have 8 and 8, right? 8 and 8 on either side, and 1 in the middle. So 1, 2, 3, 4, 5, 6, 7, 8. There's my median, 1, 2, 3, 4, 5, 6, 7, 8. Now I find the quartiles, 1, 2, 3, 4, and 1, 2, 3, 4. So the quartile here is going to be this. So that's going to be the midpoint of this, 16, 17, 18. So this is 17.5. 1, 2, 3, 4. So here's my quartile here, 12. So my IQR here is 17.5 minus 12, which equals 5.5. Range here is 10 to 29. So range is 19. So you can see I have a bigger range here, overall range, but my IQR is much bigger over here. So when it says which data most likely has a higher standard deviation, remember that this is a measure of spread. So I'm looking at this IQR and saying, well, even though I've got this data point over here, which very well could be an outlier, I think it is. We could do the math on that, but yeah, that one's way out there. But this one has a really large spread between the quartiles. So data is much more spread out. So I'm going to say that the standard deviation is likely Sequoia. And why? Because like IQR, standard deviation is a measure of spread. Now what I didn't do here is say because the box is bigger. If I had said that, that would be inaccurate, because the box here is showing me visually the IQR, which is a different measure of spread than the standard deviation. Standard deviation is something that we calculate based on all the values. It's actually related to mean. IQR is related to median. So there's sort of two different ways of doing spread. All right, next one. The median home price is 382. First quartile is 330, and the third quartile is 412. So the Feinsteins bought a home for this. The Harrises bought one for $450,000. What is the price above which an Elk Grove home is considered an outlier? So this outlier tells me I've got to find the IQR and then figure out what the IQR times 1.5 is. So IQR is a matter of subtracting the quartiles. So first quartile is 330, third quartile is 412. So 412 minus 330 equals 82. So I've got 82 is my IQR times 1.5 is 123. So then I add the third quartile, 412 plus 123, 535,000. So that is, I'm putting K's here because to note that these are all in the thousands. But because I've got 3 zeros, I can really say in the hundreds or in the thousands. How many? So 412,000 plus 123,000 is 535,000. So anything more than this is an outlier. Okay. The price below which. So now I take Q1, 330, and I subtract my IQR. Equals 207. So, which one of these homes is an outlier? Is either of these homes, that one or that one, are either of those outliers? Well, this one is not above our outlier boundary. 270 is not below our low outlier boundary, so the answer is neither. Make sure you can see that here. Okay. Oh boy, I grabbed a copy of one that did not have a back. Let's look on the back. Here we go. Okay. The dot plot below represents number of books read in a summer reading program. How many participants have read 8 or more books? So can he read a dot plot? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 have read 8 or more. Is the tail of this data distribution to the right, to the left, or is no tail? Well, you can see that most of them are here, and then all of a sudden, whoop, I got a big thing right there. So it doesn't matter that all these are stacked here. They could all be stacked here. They could all go out this way. But the point is that you can tell the middle of the bump is kind of right around here, and there's a lot more that are off to the side. So we would say that there's a right tail. So this is skewed right. Okay. The number of miles driving to school, ounces, follows a normal distribution with a mean of 2 miles and a standard deviation of 0.2 miles. The school has 1,200 students. Somebody pointed out to me today that there's a typo here. So this should be 2.2 and 2.4 and 2.6 and 2.8. So how many are within 1 standard deviation of the mean? Okay, so it follows a normal distribution. The mean is 2 miles, so here's our center line. So there's the mean. So that means here's the mean plus the standard deviation. Here's the mean minus the standard deviation. So you can see I'm moving by standard deviations, 0.2 miles. So that means they're 34% here. So 34% of 1,200 students. 0.34 times 1,200 equals 408. How many students are within? Okay, but pausing. So I notice it says within. Now that means that here there's going to be 408. And that means that here there's also going to be 408. So within 1 standard deviation means either this way or this way. Okay? So we could also say that in this whole range is 68%. Right? That's what our standard deviation grid tells us, or diagram tells us, if we look back on this. Yeah? So you've got 68%. So that means I'm going to say times 2 equals 816. How many students' commutes are within 2 standard deviations of the mean? Well, let's go back to our grid. What we're saying here is not how many are between 1 and 2, or how many are above average, or how many are in this range. What we're saying is how many are between the mean and 2 standard deviations. So that's 95%. So 0.95 times 1200 equals 1140. And then finally it says, I'm going to go back to our chart here, 99.7%. 99.7% are within that range. So 0.997 times 1200 and we can't have 0.4 of a student, so we're going to say it's to round to the number. Round to the nearest whole number. Okay. Now it says draw a histogram. So now we do need these particular percentages. 13.5%. So this is 0.135 times 1200. This is 162. 162. From here it's going to be 2.35%. 2.35%. 0.0235 times 1200. 28.2. So we've got 28 students. And last we've got 0.15%. 0.15%. So that's 0.15 divided by 100%. That is that. So times 1200, 1.8. So we're going to say that's close to 2. 2. All right, so I've got to get up to 408 maximum. And I want to be able to at least show 2 here. So let's see, to get up to 408, 1, 2, 3, 4, 5, 6, 7, 8. Okay, if I go up by 50s, right, if I say 400 divided by 8 is going to give me 50. So I go 150, 200, 250, 300, 350, and 400. Then I know that 408 is going to be about right there. And then this is going to be 162, so that's about right there. And this is, what do we say, 28. So 28 is just over half of 50. And then we've got 2, which is really just barely a line. So that's what our histogram looks like. On your test, you're going to be able to use your stats vocab worksheet. So we'll make sure that we get this diagram. And I encourage you to use the remaining class time and your weekend to study for this and come back and you'll be able to apply this on the test.